Okay, so in this video we're going to find or estimate the derivative evaluated at 1 in various scenarios. So our first scenario is the function 1 over x. So we'll start by just writing out the definition of the derivative. So it's the limit as h goes to 0 of f of 1 plus h minus f of 1 all over h. If we put 1 plus h into our function, we'll get 1 over 1 plus h minus 1 over 1 all over h. And you might think, okay, at this point I'm just going to put 0 in for h. If you do that, you're going to get 1 minus 1 over 1 minus 1 over 0, which is 0 over 0. So that's indeterminate. We need to do something else to this expression to figure out what the limit is. So this doesn't work. So what we're going to do is we're going to combine those fractions in the numerator and see if we can't manipulate this algebraically into an expression that we can just plug h into. So the way that I'm going to add these fractions is I'm going to create a common denominator, and the common denominator is going to be 1 plus h. I'm turning that 1 over 1 into 1 plus h over 1 plus h. I'm also going to take this dividing by h and write it as multiplying by 1 over h. All right, so let's continue on. Now we can combine those fractions. So we'll have 1 minus 1 plus h as our numerator and 1 plus h as our denominator, and then we'll have this 1 over h. Again, distributing that negative sign, we're going to get 1 minus 1 minus h over 1 plus h, which leaves us with negative h on the top, negative h on the top, 1 plus h on the bottom, and that 1 over h is now going to cancel with that negative h, and we'll get just negative 1 over 1 plus h. And now we can just plug h equals 0 in, and we'll get negative 1. Or if I was to write this out a little bit, negative 1 over 1 plus 0, which is negative 1. Graphically, let me show you what we just did. So we have the function 1 over x, which looks like this. And we're looking at the point 1 right there. And we just found that the tangent line has slope negative 1. And that seems to match our graph. All right, let's look at another scenario. So in this scenario, we have the function described by a table. And since we don't have a formula for this function, we just have to estimate the derivative. We can't compute it exactly because we don't know what the function does at all values. So let me just sketch for you what this function looks like, and then we'll use this sketch to figure out what the derivative is, or at least estimate the derivative. So at 0, it's 1. At 1, it's 3, and at 2, it's 4. So those are the integer points. And then at 0.9, it's 2.8, and at 3.4, it's, or 1.2, excuse me, it's 3.4. Okay? So we have a function, something like that, maybe. We don't really know what it does elsewhere, but let's just suppose it looks like that. And we want to find the derivative at this particular point right here, this 1. We were trying to figure out the derivative at 1. Now, since we don't have the formula, we're left using the points that are in this table. Now, we want a good estimate of the tangent line here. And the point that's going to give us the best estimate for the tangent line is this 0.9, 2.8 point. So the slope of the tangent line is approximately the slope of the secant line between these 2 points. Really, that secant line is going to do the best job of estimating the tangent line. All right, so we'll do rise over run for the secant line. The rise is going to be 3 minus 2.8. the difference in the y values. And the run is going to be 1 minus 0.9, the difference in the x values. So we'll get 0.2 on the top and 0.1 below, and that will give us 2. And that's our estimate for the slope of the tangent line. A picture of what we did is we found that slope between those 2 points. Okay, so in this last example, we want to find the derivative at this point. So just remember the derivative is the slope of the tangent line here. So what we should do is we should sketch the tangent line and then estimate its slope. If you draw a tangent line here, it's at a minimum, so the tangent line is going to look like that. If it was to the right, it would be a positive slope. If it was to the left, it's a negative slope. But right at the minimum there, it's going to have a 0 slope. So this derivative is going to be 0. Slope of the tangent line is 0. All right, I hope you found this video useful.